By show of hands, how many people here are involved in food safety every day? All right, really needs to be 100% of us in this room every day. That was a trick question. So I'm going to present on hygienic design, sanitary design. It kind of is an extension now what we're doing with the PMA United Fresh Listeria workshops. So we've been about once a quarter geographically. We've been doing smaller 2.5-day workshops focused on just how do we seek and destroy listeria. So the segment that Heinzen involved in is kind of blue sky, hygienic design, which I'm going to kind of present on here, but I'm going to interweave in legacy issues. Every plant in North America has a lot of lines that were built 5, 10, 15 years ago that were never designed to be sanitized and cleaned in the first place. International Fresh Produce Association, we were approached by the Director of Quality for McDonald's, and Suresh Dakas at the time was their manager, and he says, hey, we have an issue in the industry with this bacteria called Listeria monocytogenes. And I go, we're engineers. How many syllables did you just give me? Because we like to work in like 1 or 2 syllable words. So, that really dragged us as a company into actually diving in. What is Listeria monocytogenes? Where does it live? How does it grow? What can companies do to attack it on it? But it does have to have a coordinated attack on how to go through it. So, first off, teaching engineers and everybody in the industry work in Listeria high. Now I could have a lot of great photographs with this, but we would never get off this topic ever. We could spend 3 or 4 days just on every one of these topics, from laminations, surface finishes, control panels, hollow areas, tubing, cavities, floor drains, air blowers, your evaporative coolers that are hanging from your ceiling with condensation issues. And we kind of realized that maintenance and sanitation really need to come together and work as a common team, especially a lot of this equipment, the only time you can sanitize it and when it's going through a PM step, a full disassembly, taking a lot of components off. So getting food safety and maintenance to see eye to eye to actually put sanitation steps into the PM process is really critical, and it's happening now on a lot of levels. We know how it moves now. It does need a vessel, which is typically a person moving it around, but we've also learned that sanitation tools, implements, brushes, water, air with airborne bacteria condensating, different components. We'll weave back and forth in how Listeria moves, and I realize I've got 50-some minutes to go through this. I've got 50 slides, so a lot of this is going to be just scratching the surface. But this will give you the ability to start asking questions, because everybody in the food safe, in the produce, fresh cut produce industry needs to become a hygienic design expert. They need to be able to look at equipment and make those basic decisions. Is that a seed safe piece of equipment? Are we doing it correctly? Is there a chance of microbial cross-contamination? How we're touching, handling, moving the product through the system? So I had this link in an earlier slide, but I moved it to this slide. We have a saying that common sense is not too common at times, but if you read these documents, it's all there. So there's great guidance now that the FDA has published. And also United Fresh has just gone through with about a year's worth of focus meetings and rewriting their guidance documents. So I will tell you that these are direct links, so it's a backdoor. So I'm giving you guys secret access. If you go to United's website, they're going to ask you to make sure you're a registered user and capture your metadata and all that stuff, but this gives you a direct link. So don't get me in trouble. All right, so how do we go about attacking the problem? There are a lot of sanitary design guiding principles from not only the facility side, but also that apply to specific machine design. American Meat Institute, AMI, originally started this back about 20 years ago. They first implemented and came together of how to write a guidance document And they wanted to have kind of a value-driven specification, not a how-to specification. So as we go through and weave and actually you read through and try and implement the 10 principles of sanitary design and how they apply, they work every time. But you will, as you start to use this, realize that there's a lot of common themes in how you apply those principles. And we are all, I think most of us are for-profit business, or at least to pay your taxes. So becoming more efficient in how you implement sanitary design is a good thing. And standardizing then results in more efficiency. So internally, we had a little bit of a battle getting 16 engineers all to be thinking the same way. And the 10 principles of sanitary design helped us do that. It helped us embed the necessity for hygienic design. And then it also gave engineers, they like to ask questions, why do I need to do that? Why do I need to do that? And it started answering a lot of those questions. We like to make sure our employees, when they have a design problem, that they're armed and dangerous. They're critical thinkers. They understand why Zone 1 areas are important, why Zone 2 you can do certain things, and what Zone 3 areas are in the design process. And we'll be covering that here shortly. Oh, right now. So, definition of design zones. It's very big in the food safety. You walk into QA, food safety department, they understand this, they know it. They've been hearing these Zone 1 areas, they've been swabbing these areas, maybe not necessarily Zone 1s, but 2s, 3s, they've been swabbing. But go to your maintenance guys. Do they fully understand? Some of your line workers, do they understand the difference between those areas and how to treat them? So just a brief definition. There are some variances in here, but these are the general guidelines on zone principles. And if you guys, in the true food safety professionals, you guys are fully embedded in this, but it's always good to refresh. Zone 1 is really the direct food contact areas. It's the areas where if you were going to have something that bolts on to a piece of equipment, you really don't want it to be bolting on to a Zone 1 area. You want it to be outside, either in a Zone 2 or Zone 3 if possible. Having hollow areas that are connected right to the Zone 1 area can present significant issues. We all know that hollows, from tubing to chambers or small pockets that may be closed for a sensor, they're never leak proof, ever. We've cut enough equipment apart to know that even seamless tubing that's welded in as a spreader in the right conditions, there's microfractures throughout the induction welded joint, and we've been blown away that it's filled up with black gunk after about 2 years in production. So if you can design out any hollow in those areas, that's a good thing, because you never know when somebody may decide, oh, we need to mount a bracket there. Let's get a drill, we drill a hole in it, we tap onto it, and now you've penetrated that tube and it continues to leak and become an issue. Areas that can drip, drain, or be drawn onto the Zone 1 surface. Okay, those are somewhat of the gray areas. So we have some Zone 2 areas that may be a sealing surface, but if you look up at your ceiling, you continue to see yellow streaks on there, freckles on your ceiling. That's a good indication you have condensation issues. That should be swabbed, because that can drip, drain, or be drawn on a Zone 1 surface, which then, so we know those surfaces will be hot for listeria at some point in time. So for engineers, a layout plan, it's always great to be able to categorize. At Heinzen, we spend a lot of time categorizing. It saved us. When we get in trouble, we go back to the basics, what category, what area, how do we handle it. Your raw product areas are pretty self-explanatory. That's the first step of receiving in pallets, wood pallets, cardboard, plastic bins, etc. As you then start to change state from being in a bin, it goes into your ready-to-eat zone, where you're making the product ready to eat, where it's undergoing its initial microbial reduction step, stripping jacket leaves, doing some of the mechanical separation, some of the non-destructive separation steps you learned about yesterday. And then we go into high hygienic zone. That's typically after the wash system. So you've gone through, you've reduced the microbial content of the product as much as possible. It will never be pathogen free. There's no true kill stuff in fresh cut. So once you get into high hygienic, that's an area you really want to have your cleanest, purest air from your refrigeration system. You want to have all your workers trained that if you go through the plant, you don't walk through raw product through ready-to-eat zones into high hygienic. You go through the primary sanitation entry down, and then you go into a high hygienic area. So there's a lot of common sense things that aren't always common. We've been involved in a number of plants going back about 15 years in North America that have had strict hygienic zoning steps, where there's a physical wall between raw product and the trim lines. There's a physical wall after the slicers into the wash systems. There's another wall between slicers and filling dryers, whether it's automatic. And then as we go through the dryers, the finished pack out is also segregated. There's a number of plants that have never had a food safety accident or anything major that it's wide open. You can walk the whole length of the line. So, they've got great trained workers and they understand how to handle the sanitation. But that is, as we know, as employees continually turn over, if you can design in your infrastructure to create some of these natural control steps, it does really help in the whole hygienic health of your facility. So color coding, this is just a quick reference. I won't spend a lot of time on this, but for engineers, if we don't color code things and get things really super defined, it's always a gray area, right? All right, so now we're in the facility. So I'll just touch on some of the guiding principles and best practices from floors, drains, walls. And we're not a architectural company, we're an equipment manufacturer. We're involved in a lot of front-end facility design. We've seen a lot of great projects, come together. We've seen a lot of very poor projects come together. A lot of it is about contractor selection, subcontractor selection, and then the internal culture at each company. Are they going through, if you don't have a project manager internally that understands all these principles, and you push it onto a general contractor, there's a good chance that you won't get the outcome that you want to have. So floor systems, what is the risk to a compromised floor system? So, I always can judge really quickly when you walk into a facility, looking at the floor, they may be sealed very well, but if you look at the grout lines and you see trace evidences of a blackish looking joint, that's good. It's a good indication that you have a floor failure or a drain failure somewhere in your facility. Forklifts traveling 20, 30, 40 yards away will actually, you can feel them, right? And the floor will move a little bit. Well, if there's water underneath that slab, it's also hydraulically moving, pumping that water to every corner quadrant that water can reach. And as it slowly builds up, it starts to get pushed up through your floor. And you start swabbing those joints, and every one will be a catastrophe that you're going to have to report. So coatings, I think nowadays urethanes, there's so many options on urethane coatings for your high traffic, high wear areas. They also build, you can slope, you can deal with divots, pooling issues with it. Pretty much every new facility now is going with the urethane. Epoxies, there's certain epoxies that have some flexible polymers blended into them that you can use for curbs, other people access. Cost-wise, it can go from as high as 20 bucks per square foot down to 4 bucks per square foot. So you can spend a lot of money on your floors. Floor prep, we still see some issues with floor prep, especially with inexperienced contractors. I can tell you we've done multiple installs where they paid top dollar for a 2-part urethane. The floor was prepped on a Thursday night. They shut the plant. They could shut the plant down for 4 days. So they do the floor, they prep it, they go through, the floor is guaranteed. We come in Friday at about 2 in the morning, start putting in equipment. The plant starts up Monday morning, and all of a sudden the floor is coming up like a carpet. So there's a lot of caution to be had if you're doing a floor prep. Ucrete was one of the first projects on the market. Just gives you, just kind of a view of the different layers. It is a 2-part prep process. Polycrete's also another product we've seen implemented. A lot of areas, they've got great YouTube videos. You could watch these and you could become a floor installer of this stuff. They're pretty good. And also they have colors. So looking at How do you want to color code your people walkways? Are there areas around the equipment that you want to have always designated to be a safe sanitary zone? You don't want bins being put there. So there's a lot of options now on what you can do from floor codes. So, laminations, as you know, is one of the biggest hiding points for Listeria. They're all over. You're never going to be able to design them out. But can you move them? So, pre-chill water tanks that you see here, a lot of times they're set right on the floor. When the floor drains back up, not if. Now that you have them on a raised curb, yes, you still have a lamination, but now you've eliminated the potential hazard of floor drain water backing up and contaminating that lamination. Also, on walls, are your conduit drops spaced off the wall, so there's always airflow. If you do need to sanitize those areas, you can get to them. Penetrations through the facility, how are those sealed? Are they flexible? Buildings move and creep over time. There's vibration going through those. And also mobile equipment protection. If you have mobile forklift traffic in those areas, I hear a lot of times it's like the day before the auditors come in, somebody takes out the roll-up door. Or they run into another piece of equipment and it's a major crisis to get everything put back together before you have your quarterly audit. This picture, it goes back about 15 years, and it was a mobile inside, so the mobile equipment recharging area got moved inside. But a lot of things that have improved over the years is office areas that are inside maintenance areas now. These are all going to an enclosed area with a sloped roof system so that you can actually clean. Over time, up here will be an inch layer of dust and debris. And sometimes somebody may need to get up there and work, and then they migrate that dust through the whole facility. Expansion joints, wood in the plant, all those are being designed out. We're still seeing some painted mild steel components where it makes sense, by zone. So we haven't gone completely off the deep end and made those out of stainless yet, but it needs to be hygienically designed though, from a lamination standpoint and access standpoint. Floor drain systems. There's still a lot of plants that have long continuous trench drains. Most of them are flowing from your finished pack out to raw product pack out. One of the problems with those, if they do back up, you're going to contaminate the whole facility. So we're seeing a lot of drain mapping done now in new facility design, where we're looking at high care, high hygienic area. It's actually on a separate leg. So if you have a backup in your floor and drain system in the raw product areas, minimize the risk of that water backflowing up through into your high hygienic areas. Drain mapping, I tell you, there's a lot of facilities that a lot of shortcuts were taken underground. We've seen employee work areas where the plant backs up and there's a flood out where an employee break area. Well, that drain got tied in to the whole process plant. So now you've got a huge potential for cross-contamination happening there. High flow areas, having a shorter 12 by 48 inch trench drain is pretty common. If you look at, this is kind of the standard for an area drain going in, a 12 by 12 drain box. Cussell is a great company. What I like about some of their drains is per code in different areas, at each drain location, depending on the building department, who your inspectors are, you're required to have a P-trap underneath that drain. So does everybody know what a P-trap is? No. So basically it's a vapor barrier in the pipe. So the pipe goes down, it traps a pool of water, and then it comes back up. So you always have standing water underneath a lot of these drains in your system. So you can design them to have one common P-trap out by your waste collection area. It's a vapor barrier. So in your home, they're designed that you're not going to have vapors from the sewer system flowing back into your house. So it creates a natural seal. But in food plants, they can become a source of biofilm growth, plugging, everything else. So Cussell has actually designed a vapor barrier option into one of their 12 by 12 boxes. So it will pool some water in that bucket that should be part of your sanitation schedule to pool, but then it also is, you can clean it very easily. Wall ceilings, There's a lot of great wall companies now. United Fresh has added a global cold chain group to their trade show, so now they've got every company that's in the freezer business and the thermal span type of walls coming exhibiting. There's a lot of options now in interlocking and sealing, but it is the expense is your refrigeration costs when you put in a wall system. So if you're in Atlanta, hot Atlanta, you know, you want to spend a lot of money on your FRP or metal covered wall systems versus the Northwest. You may not have the heat load that comes in there. One of the biggest issues is penetrations through these walls. So there's always brackets that have to attach to them. We've been involved in a few projects where we actually used a 3M very expensive double-sided tape to attach brackets to the walls because the customer did not want to have any penetrations through the walls at all. This shows you what happens. So wall systems that were older concrete walls that were covered up with FRP that look really great. My advice is before you do that expansion, you decide to cut a wall through, to put a conveyor through it, have somebody a month or two ahead of time do an exploratory examination of what's growing and living and crawling up and down your wall system. They are highways for microbes and ants and bugs and everything else to go through your facility. We talked about subcontractors, getting them pre-qualified. You know, one of the issues are from a manufacturer like Heinzen, there's no true ANSI standard for a hygienic weld. So we're trying to work with ANSI standards, American Welding Society, to actually get a true welding spec. I'll talk about welding a little later on, what welders are trained, but also when it goes to contractors in the Universal Building Code, there's no real section on hygienic design for elimination of listeria niche points. So we see, you know, like chemical injector, it was great. It was done on a piece of polyethylene backer board, but a lot of extra surface area, and it was bolted directly to the wall panel. So we know over time there's going to be biofilm, there's going to be condensation, there's going to be sweat behind there, and down at the bottom here you'll start to see traces of little blackish droppings and trails coming out of it. This connector here, we did a job a few years back where we came in. This is a pre-chill water run, stood the piping off. The electrical contractor was the brother-in-law of the owner, got the job to run all the conduit, and he came in and put what's known as grip strut, drilled directly into the wall panel, and we stopped. Whoa, what are you doing? Stop. So we try and prevent as much of that as we can, but there's still a lot of education that has to go on in the industry. From the facility design standpoint, we talked about airborne bacteria, from hoses spraying the floor to your evaporators. I can tell you there's a lot of major processors now that they're reaching the 10 to 15 year lifespan of their evaporator units that may have had some aluminum coated fins with a polymer. They held up pretty good, but there's copper underneath. There's a lot of electrolysis happening. The fans are starting to degrade. They can't access them to be cleaned. And they were built with no thought control of the laminations controls, especially the areas that the air is flowing through. So we've been exposed to listeria plumes coming out from these, blowing out 30, 40 feet from the evap unit. Then the equipment in certain areas is also swabbing as hot for listeria also, and they've gone back and they've identified that it's that evap unit blowing across. We asked, well, how did it get in there? No one's touched it, but they go through a freeze and thaw cycle, every evap unit. So as they build up, they're taking heat out of the air, they start to ice over. At some point, they have to thaw out. So you're continually getting a lot of condensation, and all those impurities will stay stuck to those fins and tubes going through your heat exchanger. So last part of the facility is equipment anchoring. This is always a problematic area, especially as floor drains back up. You've now inoculated every lamination of the floor. So we like to see if they're heavy equipment, get them raised up, off, but grout is a common technique, but grout is also very porous. So a lot of times, yeah, we go through, we raise it up, we put it on a grout pad, and then the maintenance department is supposed to schedule in the flooring guy to coat the grout. A week goes by, 2 weeks go by, 3 weeks go by. Well, this was 6 weeks that we moved this equipment. And our maintenance guys, our installers actually are now trained. When they find it, we want to, it's time to go get tacos, because I want to get evidence of what you found. So this is something that they found 6 weeks after installation, right next to a floor drain. So when they dump the wash systems, there's spin dryers in this area. This is continually seeing a heavy amount of water, debris. And that's what they found growing. So every one of those connections will eventually become a source. And you may be doing your swabbing, checking it as sanitation goes through, but then check it after you've run for about 2 or 3 hours. As the vibration has started to move all the equipment, you will find that, yeah, it's coming out of that connection. All right, so we're through facilities, we're now into the process equipment. How am I doing on time, Jeff? 13 minutes, all right. So we're going to go through these slides really quickly. My emails, I'm available. If you want further training, the PMA United Listeria workshops are a great avenue to get more training on equipment design. This is where we went. So commercial sanitation's essentials, commercial food sanitations, they run a hygienic design program out of New Orleans, so it's a great place to send your people, or to go. And I know there's a couple of people here that I talked to yesterday have gone. They have not only a sanitation worker program, where you can actually be trained in all the protective gearing, everything else, but they also have 10 principles of sanitary design training, etc. We also bring them, they will all come to your facility, so you can hire one of their consultants to come to your facility and do 20 people at once, versus sending 20 people to Orleans. So they are rooted in the 10 principles of sanitary design, which is great. But we have, because we have to live to a budget, and we give our engineers X minutes, X hours to put a piece of equipment with 40 components into the fab shop, we've had to categorize. So we have published on our website, we have a survival guide. We now have a condensed version of this, which is about 30 points, which we're calling our OEM design guide, and we're partnering with different vendors in the industry to continue to expand and move that design guide forward. But we categorize based on sanitation operation performance. How well does it open up? Can you clean it? Is it toolless disassembly? Sanitation workers turn over every 2 weeks. So it's got to be easy to train somebody to clean this. Drive components. So, we can't reinvent the wheel through the 10 principles of sanitary design every time. So we have to standardize on where gearboxes are located, how are we mounting them, IP69 rated. These are all great principles as part of a checklist format that can really accelerate your decision making as you evaluate equipment. And we love giving this away. We love to see our competitors, we're working this, trying to make the most hygienic piece of equipment. So we're giving this away to everybody. Our competitors can use it, because we want to see better machinery being put into the industry. We get down to where we spend a lot of our time, fabricated weldings. So we spend a lot of time on how do we take welding out. In the early days, when you listen to Joe Stout, when he first started bringing some of the concepts from AMI into the fresh cut industry, he had some case studies where it wasn't always bad news where the price went up. And we've proven that. So it's made it a little more complex. You need to see the SolidWorks to parametrically model it. The sheet metal can flatten. You need precision tooling to make the sides, the frames, and everything else. But what you get is a piece of machinery that has maybe a quarter less total welding in it. And there's no hollows, there's no blind corners, there's no trapped edges, there's no flat surfaces. So we break it down into process piping. We could spend 2 days on process piping, but I don't think you guys want to do that. Motor controls, always, we get a lot of calls that FDA just opened, or our SQF auditors opened our panel, they swabbed it, and it's hot. How does listeria get in that panel? We've never even opened it. And I go, well, that's an indication of your airborne, the air in your plant. Who's hosing the floor? How close is that control panel to a floor drain? You know, is there a conveyor that's close by that they're hitting the floor, it's hitting the conveyor, bouncing off and hitting the panel? And their maintenance workers, are they trained? You know, they're in there. Are they sanitizing their tools when they go open up control panels? So there's, you know, a lot of moving parts in this whole hygienic design. Equipment installation is another area. Most companies now have a quarantine process. If you're doing a capital equipment upgrade, I got it, 10 minutes, all right. You've got to go through and isolate the equipment, do your swabs. The timeline doesn't always involve that. We've been able to do that in our plant. Does everybody see a new Audi going down the road in that nice white bubble wrap? Fully encapsulated. Well, we've done that with equipment. So we've actually bought all the shrink wrap to do a mass bubble wrap, shrink wrap. So we've encapsulated equipment. We've had, right when it goes, get sealed up. We swab all the surfaces, put the test kits in a bag, and they get shipped out. And the equipment shows up on the truck, and it's gone literally from the truck into the process room. And a lot of companies are running now 6 days, 2 shifts a week. Sunday is for sanitation and maintenance. And you have maintenance workers working from 1 a.m. to 4 a.m. now. Wall sanitation is also cleaning equipment. So the timelines is so compressed in a lot of these plants that you know, we hate that shortcuts won't happen, but anything you can do from a design aspect to compress time and doing all these things will help eventually. So, learnings from legacy equipment. This is really where a lot of companies exist now. We have built a lot of equipment in North America. Going back 5-7 years ago, it was really designed. You know, they were cleanable, but there's still a lot of things we didn't know about, from hollow tubing areas, surface finishes, zone 1 connections, etc. So a lot of companies now, as you look at your facility, what's my workaround? How do I make this existing piece of equipment food safe? Because we're not going to spend $4 million to retool everything today. So this is a great breakout session, part of the Listeria workshops, where we spend 2 hours going through case studies. We have some people that attend, bring some of their problems, and then we work the issue as a group. So we have this published on our website, that if you have a belt, drive, train, gearbox motor setup, and it's right over a combination scale, what are some of the things you can do to mitigate it? If you have hollow rollers in your conveyors, what are some of the things that we've learned over the years to start to design these out? The other part of the equation, as you go through this, is actually identify what is my matrix for sanitation on this. So we get questions at times, you know, how do we clean this piece of equipment? You know, there's 5 steps basically for a general sanitation step. If it's taking you 2 guys 3 hours to do step 1, which is blowing all the debris out of the equipment, you could say, well, if they're doing that every night of the year, times 52 weeks a year, times their man hours, there's your basic cost. Use an easy number to figure out about what it's costing. You can start to develop an ROI to go to your management and say, hey, you know, if we can get this so one guy can clean this in 30 minutes or 20 minutes, it's going to save us over a 1-year, 2-year period this much money, which could then drive management to say, yeah, let's spend some money. All right, so in the shop, we have published our own internal weld standards. We have our guys tested for welding. A lot of our guys that have gone through a 2-year junior college weld program, or if you're a union welder that's welding a high-rise building in San Francisco, you're taught to do a stack of dimes welding. So they're basically taking the electrode, welding rod, they're driving it, creating a puddle to get whatever depth penetration they need, so it's now molten, and then they pull that out, it solidifies, they move forward, they do it again. So it's that stack of dimes type welding is what gives you a super ultra strong weld. But we want one that looks like you caulked it and then you took your finger and made it nice and smooth like butter, right? That's what we want. So that's easier said than done. And I can tell you we've got 30 welders that work for us. Out of the 30, we've got about 5 that can do that as fast as anybody can do any type of weld. So we have ongoing training going on to get every welder up to work on that specification. And by zone now, we've got certain work that only 5 of our fabricators can actually touch that area of the equipment. Because for us, rework is lost money. If we then give it to an unqualified welder, they go through and they botch it, then we end up having to go through and grind all the welds. There's a technique called TIG washing, where you can then remelt it, but it really warps the equipment, makes the weld very brittle. Here's some pictures you guys can look at, just of different areas. We have a welder training program. We've offered it to a few of our customers that send their maintenance guys. We show them some pull techniques, push techniques, how to set your welder up correctly. There's different wires, different gas combinations that will give you a better weld. There's also better welders. There's pulsed arc welders out now that I can make a pretty good weld now, and I'm not very good at it. And also identifying what's a bad weld. So this weld we actually caught in our shop. So that was a new welder that those were fairly okay, but then they didn't wrap that corner. It slopes down this way, so you're going to get water pooling. These were repairs that were done at some point in time. And usually I can tell you a lot of companies, the lowest man on the totem pole is the guy that's going to go out, drag the welder out to fix the machinery. We now see a lot of companies that are going through and they're paying the welders. We want you trained, signed off that you know how to make a sanitary weld, and that's why we're going to pay you a couple more bucks an hour. And when that machine breaks down, you're the guy that's going to come back at 2 in the morning, go in the plant, clean it, and fix it. So we're sharing our fabrication inspection report, just so there needs to be some second set of eyes looking at any weld, even if it's done internally by somebody fixing a piece of equipment. There's a lot of maintenance departments that have their own fabricators in-house, and we see multiple dual standards. So you look at an external vendor, the standards you place on them for weld qualities, but then if you're building an in-house, the standards may be relaxed a little bit because there's budget savings. It's our own people, but the risks, the food safety risks, are still as great. So everybody needs to work to the same standards and put out the same quality work. So one thing we're doing as a equipment manufacturer now, we have actually rolled our hygienic design effort into a sub-company called Channelize Integrated Solutions. Got it. All right, 2 minutes. Almost to the end. We're providing a industry standard SSOP now. We have a generic version that goes in with all of our different product lines. And then we also can do if you're doing a significant build out of custom equipment, we have a full-time food safety professional working for us now. She will partner with your food safety people and we'll actually design it so it dovetails right into your sanitation program. So you can put these, when the equipment shows up, you've already got all your SSOPs written and they go right in sequentially. The last 2 minutes, just looking at some fab standards. See, we like to teach engineers that this is what sanitation workers are using a lot of times to scrub the equipment. You know, if we have large radiuses here and welds in the corner, that can be cleaned. But if we have super tight radiuses, and that's right over product, we really don't want to have that. We'd like to have that bumped into a couple different radiuses so you can get in there and clean it easier. Our channelized construction, you know, we've done a lot of these with these originally tubes. So we have product lines that we've actually migrated from tube. We've then substituted channel. That goes to a certain extent. Sometimes you need to basically go from a ground up redesign to really get it so it can open up fully without tools to be cleaned effectively. There's a lot of new versions of solid urethane belting that are out there now. It's a great product. The downside is they run into the $20 per square foot range. And they will get damaged. Although they are urethane, they will not withstand the glug, glug, glug method of titration for your sanitation cleaning protocol. So that's been great for the belt industry because as time gets compressed, Sanitation professionals will tell you there's 4 factors. There's time, there's temperature, and can you use hot water, and there's chemical solution, there's mechanical agitation. So typically chemicals start to get ratcheted up as time gets compressed, and then you've got components failing, and this is a $6,000 conveyor belt, just the raw cost of it to replace for somebody that cooked it too long. Just having drop-down pans for sanitary access, eliminating threads on adjusting feet, etched marking, just give you an overview. Rotary valves for pneumatic conveying have been a source. A lot of these pipe areas inside the pipes fall into categories that they have never been cleaned. We now, code word is NBC when we talk about that, so they exist. They're very hard to exist. You can't run a pig through these. So there's been a number of improvements in designing flexible seals for sealing the valves. Just control panels, slope the tops. There's a lot of hygienic options now on controls. And then looking at, there's always heat inside control panels with condensation that can happen. They are targeted now for a lot of swabathons. Let's open up the panels, swab the areas. There's compressed air dryers. So we've done a lot of these in the southeast, which has solved a lot of problems. They do add some costs, but basically it's putting a compressed air and a desk in it, keeping the panels pressurized to help control moisture buildup. And this could be what it looks like after 6 months of running. It's amazing. Any little bit of heat, I tell people if you can just leave it on 24/7, put a heater in it, just don't ever turn it off is the best thing. But oftentimes you have to lock out the panels if you're doing sanitation, so they will cool down. When they cool down, it's like a vacuum effect. It sucks in all that humidity, and then it's full of water. So a lot of information thrown at you in a very short amount of time. The basic operations. Tomorrow we're going to cover unit operations. How do we build the engine that makes all this happen? So a lot of blue sky hygienic stuff, but if it can start steering companies in the right direction, I think it's a great tool to use. So, thank you.